It's so good to be back at the NDS conference and see so many familiar faces and so many new ones. Last year, if you recall, at the NDS conference, TomTom presented how we are using the NDS.Live standard to transform our navigation stack and bring new user experiences to market with the Orbis maps. This year, we've taken on a different challenge. We'll be talking about the challenges in the automation market, our response to those challenges, and the critical role that NDS.Live is playing in the journey of turning data into a beautiful automated drive. Before I begin, quick round of introductions. I'm Juniper Gujral. I'm the Senior Product Manager for Runtime Maps at TomToms. And my co-presenters for today are Shubham Bhusari, who leads the product management for our ADAS and ADAS software solutions, including surround navigation. And then I have with me Peter Van Hulten, who's the tech expert of our gang. He leads the engineering organization for Runtime Maps. Okay, now it is no surprise to this audience that the demand for location technology in the automated driving space is growing. There are so many consumer data trends out there, and these are just a few. 58% of EU vehicles by 2030 will have an L2 or higher levels of autonomy. 72% of EU consumers want ADAS and AD functions in their next car. 42% of EV users will want to switch brands just to get better ADAS and AD features, and the list goes on and on. While the demand side looks so fascinating, the supply side is still a bit behind. We do have robotaxis in key cities in US and China, hands-off functions on highways, but for most urban scenarios, we do not have scalable automated vehicles yet on road. And the few there are still struggle to make right decisions under certain conditions. So what do we feel are the three key challenges on the automation supply side? The first is scale. How do we offer a scalable, reliable automation solution for not only highways, but for all kinds of road classes? The second challenge is unification. How do we bring together the two traditionally different worlds of in-vehicle infotainment and automation into a seamless driver experience? And the third challenge is cost. How do we all do this at a cost which is viable for us? And you know what? Today, the silver bullet, like last time, is NDS.Live. We will connect NDS.Live through all these three themes and tell you how NDS.Live is playing an important role in addressing these challenges, at least for us today. To unlock the challenge of scale, we cannot rely on a single sensor or a bunch of costly sensors in the vehicle. We need a reliable and cost-effective set of sensors. And we believe a key part or key component of this combination is a detailed map built around lane geometry. It brings in the value of long-range visibility and right accuracy at the same time. To make it a bit more practical, let's look at a few scenarios where we feel onboard sensors typically fail. The first we've all experienced in Tokyo, going around in urban canyons where GNSS localization fails more often than not. Then we have complex intersections, which are quite often unmarked, and just a vision-based system does not help. You need some other guidance for the vehicle to drive safely through those complex intersections. The third is creation of more human-like or natural driving styles and not a truly legal driving style. And then there are some obstruction-based scenarios where onboard sensors typically fail. Heavy traffic, large vehicles, hill crests, blind turns, and very commonly seen damaged infrastructure, road markings are washed out. So for all these scenarios, we would typically rely on a lane level map with around detailed geometry to help the vehicle continue the automation experience. Now that we've established there is need for such a reliable and cost-effective sensor, let's look at the options we've had so far. So I'm pretty sure everyone is familiar with this image. We've had camera-based HD maps for a while. And then the other option we've had in the market so far is a survey vehicle-based HD map. All players, TomTom here, everyone has gone ahead and produced these maps in the past. And both have their pros and cons. Camera-based map relies on fresh sources and can be scaled easily, but it is fraught with systematic errors due to limitations of the front camera. And on the other hand, we have survey vehicle-based map, which is highly accurate, has good quality, but freshness and cost effectiveness is often a challenge with this map. So what is the solution? Today, in today's market, we have a third solution, and this comes in the form of TomTom Orbis maps, especially the automation layers of the TomTom Orbis maps. It brings the best of both worlds. We do not rely on one or two sensors, like I pointed out earlier. We rely on a multi-sensor approach, a multi-source strategy to fuse all of that data together in an AI-powered platform. I mean, you'll hear this word over and over again, AI-powered platform, but we also ensure quality with human-in-the-loop processes. So all of this together gives us the confidence, gives us that balance between scale, freshness, quality that we desire in such a sensor. And the added advantage, it comes as a part of the one map ecosystem. So your navigation, custom content, everything works seamlessly with this map. Okay, now to the most awaited part of the presentation. So how does NDS.Live help here? To simplify this situation, I've created a very high level image of the map production and delivery lifecycle. It begins with change detection from multiple sources, whether it be SDO, survey vehicle, aerial imagery, and all of this fuses into the AI platform based on the intrinsic quality characteristics, frequency, recency of the content, and turns into a map, which then goes into a very strict quality assurance process. Now, a new key component of this quality assurance process is the NDS.Live based lane level localization quality framework. I'm pretty sure all of you are familiar with the term, but just for the sake of completeness, localization is the ability of the vehicle to position itself in a digital map of its surroundings, and it forms the basis of hands-off functions. And it is but obvious that we measure the quality of our map against this function. So what do we do is very simple, actually. We take map samples from different perspectives, different areas, different types of road coverages. We run those samples through the localization quality framework, which includes real-life test drives built on vehicles powered by NDS.Live content. We run those tests, we analyze those tests, and that feedback and all the longitudinal and latitudinal localization metrics feedback as a strong signal into the map production. We do this over and over again till we reach quality thresholds and then do large-scale release of map changes, again through NDS.Live. So that's how NDS.Live plays a key role in the production as well as delivery of these automation layers. Okay, enough of talk. I will show you some few clips of the localization quality framework test drives. The first two clips will be showing you how the camera-based sensor isn't enough, or the onboard sensor isn't enough, and the map acts as a reliable source of information. The third clip is where we'll show the map actually has an incorrect road edge detected, whereas the camera is a reliable source. We feed that back as a correcting mechanism. The first scenario here is something we experience commonly on highways where heavy vehicles, trucks cross vehicles very often. And because of the limited visibility of the camera, the lane borders are incorrectly detected. And we see the map always acts as a correct source of input for the vehicle. So just to orient all of you on the screen, the top left is where you see the camera view, the front camera view of the vehicle. The top right is where you see the lane model coming from the NDS.Live power delivery mechanism. The bottom left, you see the GNSS trace, the GPS trace of the vehicle. And bottom right is where I want you all to focus. It is the comparative view between the lane model of the map on the top and the lane model of the camera observations. So as we drive along, as I play the video, as the car drives along the truck, near the truck, you'll see the camera-based observations flicker, the lane types, the lane count changes, whereas the map remains a stable input. And just in full disclosure, this camera-based setup is not our in-house development. This has been taken from a leading provider in the market. So this actually shows what happens in a state-of-the-art setup. You see the camera-based observations flickering. The video pauses for a moment to let you see that the dashed line is now represented as solid, whereas the map continues to provide a stable input on lane model. All right, on to the next Sorry, hopefully this helps. Yes. On to the next slide. The next scenario is where a camera based detection, and even for that matter, a camera based map alone, will not help. These are scenarios where you're trying to navigate through complex intersections without road markings. So you need some guidance from another sensor, and in this case, a map. So if you see the vehicle over here is waiting at a junction, it's an urban setup, urban scenario. It's trying to take a left turn. You already see that there are no markings. The camera model is practically going down. But there are some trajectories for driving which are available through the map to follow. I'll play the video. It'll again pause for a moment for you to see where the camera observations disappear and the map provides a stable output. And it continues on the outbound lane. And then to the last scenario. Yes, this is where the localization quality framework comes into play. We see a missing road border on the left edge of the road, perhaps due to an ongoing construction or road closure at the time of capturing the map. But then we see the camera correctly detects it. We take that back as feedback and provide it to the map production platform. So if you see over here, again, on the top right screen, you see the the left edge of the road is already disappearing. It will happen for a while till the edge reappears on the map. And in this case, you see the camera correctly detects, and it's a single carriageway. Again, urban scenarios, we're not talking about only highways. And then the road edge appears again. So this gap is detected, identified, and fed back into the system. All right, with that, we come to the end of the first challenge, which is scale, and I pass on the baton to Shubham, who'll talk about unification and the role NDS.Live plays.
Thank you so much, Juniper, and good morning, everyone. My name is Shubham Basari, and I'm going to talk to you about the next section of this presentation, which is the need for bringing the worlds of navigation and ADAS together, how this can influence the context-aware driving experience, as well as what is the map and the architecture and the interface needed to deliver such an experience. Let's start with first how ADAS improves navigation. Imagine a vehicle trying to merge onto the road, as you see here, and information from the ADAS systems, such as perceived vehicles on a merging lane or blind spots, helps the navigation system and the driver to know exactly when to time their merge onto the highway. Now let's look at how navigation improves ADAS. Let's look at this scenario where you have either a lane keep assist system or a lane change assist system. And again here, a route aware system allows the ADAS system to prepare and warn the driver, make any braking or lane change appropriately to again ensure that this doesn't happen abruptly and a comfortable experience for the driver. Let's also talk about the 3 different levels of driving task that the driver has to be responsible for, and also this evolves as and well automation level evolves. The first one is strategic. This is basically the kind of route that I would need to take to be able to reach a destination. So decision on route. And the second one is preparing or planning to be able to make an exit or a turn to be able to reach my destination. And lastly, the operational tasks of actually applying force or steering or changing lanes to be able to prepare for my exit. So these is basically different levels of automation, different levels of driving task. But what is actually context-aware driving experience? So at TomTom, what we believe is it is important to provide the right context to the driver, which is basically a combination or a fusion of map data and sensor data, as you were seeing in the earlier videos, but also more importantly, presented at the right time and at the right display. As you know, there are different displays within the car. You have the central display, the augmented reality in the windshield. How do you distribute information between these displays? That is a very important aspect. And of course, doing this across the different driving tasks as well as automation levels. So this is what we believe is important to enable a trustable and safe driver experience. At TomTom, what we are currently busy with is simulation experiments and UX research, because it's very important for us to understand the needs of drivers across different levels of automation and driving tasks. So what you see here is basically a representation in these diagrams on the bottom right of the different variations of information presented in the cluster and the central display. And the key goal here is to understand the gaps and the needs of drivers across different scenarios. Let me show you in the next 3 videos some examples of what our participants experience in these simulation experiments. A quick disclosure, this is in a simulation environment and the sensitivity of the steering wheel is quite high, so you might see some vehicles colliding. I assure you there was no one harmed in these experiments. So on the bottom left, what you see here is the cluster display, where we fuse the perception information onto the map. And on the bottom right, you see the navigation on the central display. And at the top, you see the real-world simulation. So in the first video, it's a highway scenario where there is a road that is blocked because of an incident. And on the bottom right, you see that there is a blockage, but you don't know which lane. And then on the bottom left, through the cluster display, we exactly highlight which is the lane, which is soon going to be marked as a red carpet. And this helps the driver to basically switch on to the lane which is not conflicting with their route. And this is basically supporting the driver to avoid spending time in a lane which they don't actually have to spend time in. In the next video, what you see is in an urban context around vulnerable road users. What you're going to see here is how information about the relative distance of a vulnerable road user, which is bicyclist, presented at a timely manner in the cluster helps the driver to avoid an unsafe conflict. So what you're going to see on the bottom left is, again, information of where exactly the bicyclist is, and this helps the driver to time their turn without any unsafe conflict with the bicyclist. Again, showing the importance of timely perception plus map infused experience. In the last video, you see another urban scenario, but in this scenario, you're going to see the view of the driver blocked by another van or a truck or basically an occlusion. What you're going to see here is, again, the combination of perception information of conflicting vehicles, conflicting directions, as well as map information allows the driver to, again, plan their turn in a timely and smooth manner. This is not just simulation experiments. At TomTom, we're currently also busy with real-world experiments working with leading OEMs and perception providers, where we, of course, use NDS.Live as our map delivery format, but also use ADAS v3 as another standard for us to communicate or transfer data between different ECUs. Talking a bit more about ECUs, let's talk about how there is a shift in the SDV architecture. We also heard it a few times in the presentation today. As we all know, currently we have a distributed architecture where navigation, ADAS are all performed in different ECUs. And we're also heading towards a zonal architecture where you have different domains for different use cases grouped together, like ADAS and cockpit. And then we're, of course, going into a central compute processor-based architecture as well. But for today, we're going to focus on the zonal architecture and the importance of a gateway domain controller, which is basically the place where all the information that is needed for navigation, ADAS, or any other use cases is fed and then distributed across to different domains. In this architecture, it's very important to understand and to ensure that the over-the-air costs are efficient, but also the orchestration of the data happens in an efficient manner. This is exactly where NDS.Live plays a crucial role. It does this in 3 ways. Number one, with our TomTom Orbis map, as Juniper explained, we also have all of the different layers, road level, lane level, static, and dynamic information all stitched together in the same map. And this one map architecture also helps us to have a simplified system validation across all of those domains that I talked about. And it also enables to have deduplication between the information shared across different ECUs, which enables more lean total cost of ownership. And lastly, and very importantly, it also enables a smarter delivery because it enables you to have data only that you need, so tailored content, as well as only when you need it and when there is a change in the information. But to talk to you more about the cost implications and viability of NDS.Live as a format, I'm going to invite Peter, my colleague, to dive deeper. Thank you so much.
Thanks, Shubham. So with this, we come to the third part, which is a boring part, cost. but unfortunately a necessary part. Yeah. So we've seen that we want to build a scalable, context-aware driving experience. And if you want to deliver that into the vehicle, it will cost money. But we want to make a product that is business viable. We have to. So we're going to have a bit of a deeper look into what kind of what we need to do to make that product business viable. And what we propose here is a set of standardized map tile configurations to deliver the map content at scale into the vehicles. But let's first dive a bit deeper into cost. Those of you who are familiar with software engineering might know the triple constraint between functionality or scope and lead time and cost. So if you want more features in your software, that will always mean you either have to spend more time on it and or spend more money on it in the form of development cost. We have looked at it and we wanted to know if you're talking about services and specifically map content delivery services, does that same triple constraint also exist? And to some extent it does. It is not the scope of features. In particular, it is the scope of a map in the form of geographical coverage, precision, and also indeed level of detail. And on top of that, you have for the time, we don't have a real lead time, but we do have freshness. We talk about reality to application in TomTom. What you want is that if something changes in reality, that change is propagated as quickly as possible into the map and into the vehicle. For example, if you look at lane modifications at the road, that they propagate as quickly as possible after that happened in reality into the vehicle so that the ADAS features can make use of it. All that will result in more cost because there's more detail necessary for AD and ADAS features. There is more freshness required, so you have more frequent updates that will result in more cost in the form of operating expenses. Most of us are familiar with those operational costs, especially in the over-the-air cost. And we want to drive the over-the-air cost down. You have the two primary levers for that are the update size and the update frequency. But there's another side to operating cost, and that is the cost of sales. That is directly impacting, in our case, us, and indirectly, of course, also the customers, because we have to make those costs. There can be a lot told about cost of sales. I can talk about it for hours because in the cloud, keeping your OPEX under control is really difficult. For today, I want to focus on three primary levers that we have to look at. One is the infrastructure. If you look at infrastructure, building a service is easy in the cloud, but building that service at scale, high reliability, worldwide coverage, taking into account all kind of legal constraints, like in Korea, for example, or in China, is very difficult. And if you look at the basic infrastructure for delivering NDS.Live worldwide, at scale, highly reliable, that is a pretty expensive baseline already to start with. Then the second one is compile. Those of you who are familiar with NDS.Live compilation know that it can be tricky. Some layers are straightforward, other ones are very complex to do the data transformations. And then last but not least, we have egress. Egress is the actual serving of data to, in this case, the vehicle, but to any consumer. And that can be high-level split, again, into two parts. One is egress via a content distribution network. A content distribution network is a highly or hyper-optimized way of delivering static map data or static data in general towards an end user. It is what websites use, it is what YouTube uses to get the data towards you. But it works with static data. If you have data that you need to compute on the fly or that is highly dynamic, then typically you use a form of API egress, where you actually get the data via the API itself. But there's a cost difference. CDN is on average 25% cheaper than API egress. But again, it really depends on the situation. There's so many variables involved, but there's a kind of average that is what you can take. And then there are a lot of other costs that I'm not going to talk about, like the cost of storage, the cost of maintenance, etc., etc. But there are many, many more costs that you have to look at. So if we look at those three, how can actually NDS.Live help here in keeping a close eye on those costs and having a cost-effective solution? Well, one of the main key features of NDS.Live is what is called scalability. We already use scalability in a different context, so I will call it configurability here, just to avoid confusion. But in NDS.Live, we have the flexibility to configure the NDS.Live tiles for the specific vehicle configuration. And that can be tricky, because if you have 5 customers with each 5 different vehicle configurations, the permutations can, worst case, end up with 25 different configurations. And if you all have to serve them, all those different combinations, you also have to produce them. Now you're going to do that without spinning out of control with the cost. Well, luckily, in our interactions with customers, we saw that actually there is not so much variability. If you talk with them, actually most customers want one of those configurations that you see here. And that actually helps us to define standard map tile configurations. And if we have standard map tile configurations, then we can actually maximize the economy of scale. I can compile such a map tile once, and then not only serve it to one customer, but I can serve it to any customer that needs the same map tile. And using state-of-the-art access management, we can actually control that every customer gets the map tile they want. Second is, I can also keep a control about my compile cost. If I only have to compile it once and serve it to many people, that saves me a lot of cost. And third, I can use the same pipeline that I made for customer 1, I can reuse for customer 2 and 3 and 4. And with that, I actually get also an economy of scale on my infrastructure. I can reuse it to the max. But that's just a start. There are more complications, and we're still investigating those, to be honest. But if you look at customers, they can have customer-specific data, like operational design domain data for their vehicle configuration. And we have some options on how we can both keep the standard map tile configurations as well as delivering customer-specific content to a dedicated vehicle. But we still need the data, the real data from the measurements we are currently doing in our large-scale tests to see which of the options actually would turn out to be best. And another one that we still have to investigate is module version diversity. NDS.Live is a relatively young standard. We all hope it will continue to grow and evolve, but with that, we will get multiple versions of the modules, and we need to take care of that as well, because customers can stay behind, in principle, on an older module version, and then you still have to compile multiple times. So this is just step 1 for us, but we are already testing this large scale in the field, and we get very promising results already on working with standard map tile configurations. And that brings us to the last slide, where we want to summarize actually how we are tackling the challenges that we see for using NDS.Live or using the map in automation context. First of all, we have seen how we can achieve scale overall different road classes. Second, how unification really helps to deliver a unified experience to the customer. And last but not least, how we can keep control of the cost and deliver a cost-efficient solution to our customers. Yeah, I thought, where's the animation? We would love actually to work together via the consortium to share our experiences and learn from your experience, and together work on making NDS.Live evolving into a robust standard also on the aspects of cost efficiency. And we hope to work together with our customers on proof of concepts where we can do end-to-end validation of these concepts we just shared. And with that, I would like to thank you also on behalf of my co-presenters and wish you a very good conference. Thank you.